Hey everyone, I am so incredibly excited to have you here today because we're going to be tackling one of the most visually stunning cosmic mysteries in our entire solar system. I mean, have you ever actually stopped and wondered what it would be like to just stand on another world and watch the sun go down? Well, today we are traveling millions of miles away to decode a truly fascinating phenomenon. We're answering a huge question. Mars bis sunset blue color ka kyun hota hai? I know, it almost sounds like science fiction, doesn't it? But it's pure science, and by the end of this explainer, you are going to understand the exact mechanics of how it all works.
To really appreciate this, we have to look at an absolutely beautiful cosmic irony. Think about our own planet, Earth. We famously call our home the blue marble, right? We've got these vast blue oceans, a brilliant blue daytime sky. Yet when the sun sets here, it completely paints the horizon in these sweeping, dramatic strokes of red, orange, and gold. Now contrast that with Mars, the red planet. It is quite literally covered in iron oxide, basically rust, and that gives it a very distinctive reddish-orange daytime sky and a totally barren red surface. But, ironically, as the sun dips below the Martian horizon, the sunset is this piercing electric blue. So the main thing to remember here is this. Mars पे sunset blue color का होता है, Earth पे red, लेकिन Mars के dust particles light को differently scatter करती हैं, is a completely flipped reality.
So let's dive into this, because that massive visual paradox really begs the question, लेकिन ऐसा क्यों होता है? I mean, why in the world would a planet completely covered in red dirt produce a bright blue glow at the end of the day? It just feels deeply counterintuitive. Imagine you're standing out there on the surface of Mars in your spacesuit, watching the horizon. Your brain would absolutely be trying to make sense of this sudden, drastic color swap. To solve this mystery, we actually have to look past the dirt on the ground and look up. We have to look at the invisible mechanics happening right above our heads, in the atmosphere itself.
All right, moving into Section 1, the science of light, how atmospheres act like cosmic filters.
Okay, so before we can fully grasp what's going on with Mars, we really need to understand how light travels in the first place. Light speeds through the vacuum of space in a perfectly straight line, but the second it hits a planet's protective blanket of gases, boom, everything changes. That physical interaction is a process called light scattering. Basically, it's where particles and gases in a planet's atmosphere redirect sunlight in different directions, all based on its color and wavelength. Now, when you and I look at sunlight, it mostly appears white. But as you might remember from playing with prisms back in science class, white light is actually a tightly packed bundle of all the colors of the rainbow. And each of those colors travels in its own distinct wavelength. Red has this long, lazy wavelength, while blue has a very short, choppy one. So, when that white light crashes into the particles in an atmosphere, those particles act like tiny little bumper cars, scattering specific colors in totally different directions depending on their size.
Now, what's really fascinating is how completely opposite these two atmospheres are when you put them side by side. On Earth, our atmosphere is thick. It's heavily packed with nitrogen and oxygen molecules. And these tiny gas molecules happen to be the perfect size to scatter those short, choppy wavelengths of blue light away, in all directions. That's exactly why our daytime sky is blue. Now think about Mars. The Martian atmosphere is incredibly thin. We're talking about 100 times thinner than Earth's. And it's not packed with nitrogen and oxygen. No, it is absolutely loaded with iron oxide dust. Because of this totally different composition, the Martian atmosphere does the exact opposite. It scatters the red light away.
Which brings us nicely to Section 2, the Martian culprit. Because, spoiler alert, it is all about the dust.
You honestly cannot understand Mars without understanding its dust. Because the atmosphere there is so incredibly thin, you might logically think it wouldn't even affect the light that much. But Mars is famous for these massive dust storms that kick fine iron oxide particles, literally microscopic, floating rust high up into the air. These specific rust particles are ubiquitous. They are everywhere, constantly suspended in that thin air, and they are highly effective at absorbing and scattering the red wavelengths of light. While Earth's gas molecules bounce blue light all over the place, the Martian rust particles bounce the red light around. And because of that, it allows the blue light wavelengths to just pass straight through, almost entirely unbothered.
So let's trace how this builds into the actual physical journey of light on Mars. Picture a single photon of sunlight leaving our sun and making its way to a Mars rover's camera lens. Step 1, the sunlight hits the very upper edge of that thin, super dusty Martian atmosphere. Step 2, during the middle of the day, when the light is shining straight down through a relatively thin layer of air, those suspended red dust particles scatter the red light everywhere. That's what illuminates the daytime sky in that hazy, rusty red color. But step 3 is where the magic really happens. At sunset, the sun drops low on the horizon, right? Now that light has to travel horizontally through a much, much thicker slice of the atmosphere to reach your eyes. It's traveling through miles and miles of extra dust. And this extra distance acts like a heavy filter. It filters out the red light completely, bouncing it away, and lets only that unscattered, pure blue light punch straight through the dust to reach the observer.
And because of this incredibly specific filtering effect, it creates something really unique, the blue halo. It is a wildly different visual experience from what we're used to down here. On Earth, our sunsets paint the entire horizon in these wide, sweeping bands of red, pink, and orange. You know the feeling, it's like the whole sky is on fire. But Mars? Mars doesn't have a painted sky like that. Instead, it features this localized, highly concentrated blue halo directly around the setting sun. Since the red light is being scattered away, and only the blue light is cutting straight through the thickest part of the dust at the horizon, you get this sharp, piercing blue glow that tightly hugs the sun itself. The rest of the sky stays a dim reddish gray, but the sun is just encased in this brilliant sphere of electric blue.
And this whole phenomenon brilliantly illustrates one absolutely core rule of planetary science. There is exactly one true atmospheric fingerprint per planet. Mars has its one unique fingerprint, extremely thin air saturated with fine rust dust, and that completely dictates how we experience a sunset on its surface.
There's a thought here that I absolutely love. The sky isn't just a canvas. It's a window into a planet's atmospheric fingerprint. Think about that. When we look at those amazing photos sent back from the Curiosity or Perseverance rovers, showing that icy blue sunset, we aren't just looking at a pretty alien picture. We are literally seeing the chemical and physical makeup of the planet's atmosphere rendered right in front of us in color. The light itself is telling us exactly what the alien air is made of. It makes the diversity of our solar system not just scientifically fascinating, but profoundly, deeply beautiful to think about.
Which brings us to a pretty mind-bending question to wrap up our journey today. If iron oxide dust changes Mars' sky to a piercing blue, what color is the sunset on an exoplanet with two suns? Or what about a massive gas giant where the atmosphere is quite literally raining molten glass? The universe is unimaginably vast, and every single planet out there has its own unique atmospheric filter. The possibilities of colors, halos, and skies just waiting to be discovered are absolutely endless. Thank you so much for hanging out and exploring this cosmic mystery with me today. Keep looking up, keep asking questions, and I'll catch you next time.